My name is Nita Couchman, and I'm the president of the Orcas Island Garden Club, and I want to welcome you all to our April presentation with Dr. Linda Chalker-Scott. We're very excited to hear what she has to tell us today. I have a couple of announcement reminders. I hope that you all received our April newsletter in your email box yesterday and had a chance to look it over. If you didn't and would like to see the newsletter, you can either email me or is it up on the web page yet, Helen? Probably not yet, but it will be. Two things I want to remind you about from the newsletter. April 24th, Saturday, is the Great Islands Cleanup. It's an Earth Day activity to help beautify our island. The Exchange is organizing that. So if you're interested in putting in a little volunteer time to clean up the island and make the world a more beautiful place, that is a nice activity to do. Also, I just want to do another little plug. We're having a photo contest for this month. Spring photos. We have details about the photo contest in the newsletter. So anybody who has some lovely spring photos that you want to share and enter into the contest, the first prize is going to be 2 tickets to the June garden tour, which is going to be fabulous. We're all looking forward to that. Think about that, send in your photos, and I'm going to turn the program over to Lena, who will introduce our speaker. Thank you for all being here.
Okay. I'm just very pleased to be introducing Dr. Linda Chalker-Scott. She doesn't probably know it, but she's been a long time mentor of mine, and excuse me while I make sure I can see my notes here. For some reason they're going, yes, okay. Because when I was first started training as Master Gardener, she was one of the presenters, and she has a wealth of information that she shares in her blogs and so on that's available to all of us. Some of you may be familiar with it from our Garden Club website, but it will also be posted and available with the edited version of her talk today. Before I introduce her formally, I would like to do some housekeeping things. For the best listening and viewing experience during the presentation, please mute yourself and turn off your personal video. Also, please select speaker view. And as you have questions during the talk, please submit them to the library using the chat function. Our wonderful Holly King will organize them, and they will be answered by Dr. Chalker-Scott at the end of the talk. I'm pleased to introduce Dr. Linda Chalker-Scott. Linda is Washington State University's Extension urban horticulturalist, bringing science-based information to gardeners and landscape professionals. She is the award-winning author of 5 books, including the latest edition of Gardening with Native Plants of the Pacific Northwest. She is featured in the Science of Gardening video series produced by the Great Courses and was the first recipient of the Cynthia Westcott Scientific Writing Award from the Association for Garden Communicators. She also manages the Garden Professor's blog and Facebook group, which educate and entertain thousands of international followers. Linda shares her expertise in many ways. As I've already said, links to her blog and other resources can be found in the Orcas Island Garden Club website, and links to those will be included with the recording of today's presentation. Linda, thank you very much for joining us. We will mute, close our videos, and select speaker view to enjoy your presentation. As we have questions during the talk, we will submit them using the chat function.
Well, thank you so much, Lena. I'm really pleased to be with you virtually, if not in person. I think this is the 3rd time I've spoken to this group, and I've always enjoyed coming up and enjoying Orcas Island hospitality and the beautiful library setting that's there. But I'm now stuck in my kitchen / family room. So not quite as lovely as the library. So just a couple of things before I get started, just because we are doing this by Zoom, because there may be snafus. We're currently having a major electrical overhaul done. So we're on generator power right now. We've got most everything shut off except for internet and my computer. So I don't think it's going to get kicked off. If it does, there'll be a brief pause while I use my phone as a Wi-Fi hotspot, but the show will go on. I'm going to make sure that happens. I'm just hoping that it's nice and smooth and technologically boring. The topic won't be, but hopefully the snafus will be. So there is a handout that I sent, and it has the text from these slides and more, and also has links to resources that you can find, and those are all free resources. So I was asked to talk about garden myths, and even if you've heard me talk before, there's always new myths, there's always new bubbles to burst, as it were. So the things that I'll mention today, I don't think I've probably talked to you about. So we will start with looking basically at how we're going to approach this next hour. And I'm going to briefly go over how we should evaluate information when we're looking at different practices and products and beliefs. And then we'll have some examples. I don't have time to do them all. It would take me all day, if not longer, to do all the various products, practices, and phenomena that gardeners hear about, see, and oftentimes believe. And as I tell my audiences often, many of these things were things I believed when I was getting my PhD in horticulture. So it's, you know, a lot of these things are compelling. People can be persuasive, and we just have to back off and look at the science first. So I tell people that what we ought to do when we're assessing information is put the information, whether it's on the line or in writing, or you're hearing it from somebody else, through what I call the credibility objectivity sieve. And this is also what I call the crap test. And the crap test means you're taking your raw material and you're putting it through this sieve, and hopefully you'll get gold, but sometimes you'll get crap. And crap stands for credibility, relevance, accuracy, and purpose. And I'm not going to go into the details on each of these. In one of the resources I have for you is a free downloadable scientific literacy manual. And that will help you learn how to do this if it's something you're not familiar with. And here is what it looks like. And as I said, it's free, it's downloadable, it's peer reviewed, and it's really written for the layperson. It's not meant to be a scientific tome. And it really is pretty fun when you start doing this to learn how you can become a more critical thinker about gardening information. So there are three categories that I've come up with of the information about products, practices, and phenomena. And the biggest one, unfortunately, is the one that's the no supporting science category. And this just means that there's either no research at all, or there might be research, but it's inconsistent, meaning sometimes it's positive, but sometimes it can be negative. So you don't have a consistent, reliable source of information there. Or it could be that the research itself is of very poor quality. And with the advent of online resources, especially scientific journals, that's also come with an increase in predatory journals. Predatory journals are the ones where people, all they have to do is pay money and they can have whatever they send in published. So you get some real, literally junk science. And it's very difficult sometimes for non-scientists to start, combing through this and figuring out what's good information and what's not. So the example I'm going to talk about that has no science behind it at all is lasagna mulching. And lasagna mulching, by its name, is something that is very emotionally appealing because everybody loves lasagna. In fact, I think one of the times when I was at your group meeting when you had your lovely buffet lunch, I'm pretty sure there was lasagna there. So everyone loves lasagna. And so we take that love of lasagna and we kind of put into this do-it-yourself thing in terms of how to prepare soil. So there's a very emotionally charged appeal to this. So what the good thing that I will say about lasagna mulching is it is an effort by gardeners to try to get away from tilling your soil. And the more we do research on soil health and soil biota and carbon sequestration, the more we realize that tilling is about the worst thing you can do to soil. So this is a no-till method of soil prep. And so it involves putting down noodles, and noodles is the cardboard, and then sauce, and the sauce is compost, and you just make as many layers as you want. And so people, you know, it's a do-it-yourself recipe, and that's another thing that people like. So it's lasagna. It's supposedly gentle on the earth, and it's emotionally appealing. So it's been particularly difficult to battle these types of myths because you know, we want to believe that it works because it sounds really good. Unfortunately, there's absolutely no science behind this, and so all of it has been through popular literature. And other you know, non-reviewed sources of material. And what we have to do is step back and think about the parts of this. And so the parts of the lasagna, of course, is the cardboard and then the compost. And the cardboard is corrugated cardboard, and sheet mulches in general, and corrugated cardboard in particular, are very difficult for water and air to move through. Okay, so and you can tell if you think about this logically, when you order pizza, you don't end up getting a whole bunch of sauce and stuff dripping through the box because that cardboard during its processing is impregnated with waxes that make the paper material less able to absorb water. So, I mean, cardboard does break down, but it takes a while because, as I said, in the processing of corrugated cardboard, there are materials put in there to make it hydrophobic. So it's naturally made to resist water, and anything that resists water is going to resist air movement too. So think about this, you know, you're putting a material on top of a soil, and the soil is literally a living, breathing system. And you're putting something down on top of it that's going to interfere with that ability for it to breathe. And so people that use lasagna mulching often say they're smothering weeds, and smothering is the perfect verb, but unfortunately, the weeds could care less about the smothering, and what dies are the things in the soil that need oxygen to breathe. The second thing to think about is that the sauce part, the compost part, can create nutrient overloads. And as gardeners, we tend to think about organic material as always being a good thing. And if a little is good, then more is better. And that's actually not true. And you can have real problems with nutrient toxicities when you add too much. So these are the components of lasagna mulching. And as I said, there really isn't any science to support either of those components by themselves or even together. So we need to think about the soil, and the fact that the way that soil scientists start defining soils is that the original type of diagram like this kind of circle of soil used to have a little pie piece in it that was called organic matter. And this is the newest version of how soil scientists talk about soils. You notice that there is no little sliver that says organic matter. And we'll talk about why in a minute. But half the soil system should be solid, and that's the particles of clay, sand, or silt, and then bigger things like pebbles and rocks. And then the other half of it should be void, and half that void is filled up with water, and the other half is filled up with air. So that's what makes for a oxygenated, well-drained soil system. The organic matter is variable, and as I said, we're going to talk about that in just a second. So because there was no science on this whatsoever, and I wanted something behind my caution about using sheet mulches like cardboard, we actually did some research and published it on what happens with the ability of oxygen to move through soil if you cover the soil with various types of mulches. So here's the system that we devised, and these are little mesocosms. And a mesocosm is bigger than a microcosm. And these are buckets that can be sealed to be airtight. And all of them are filled with soil. And this one is a control, so it has nothing over the top. This is a bare soil mesocosm. And then some of them were filled with wood chips, like here. Some were covered with things like plastic. And then what we did with the soil, which has microbes in it, so they're using oxygen, is we measured the amount of carbon dioxide and oxygen both above the soil and within the soil. And the way we did that was with these little gas sampling ports, and I'll show you how those work too. So it's a very simple system, and with the only variable being what's sitting on top of the soil. So we tested bare soil as the control. We used black plastic mulch as probably the very worst sheet mulch you could choose. Arborist wood chips. We used landscape fabric for another treatment. We had landscape fabric with arborist wood chips on top, because a lot of people will put the fabric down, then put the chips on top to disguise it because it's ugly. Cardboard, and then cardboard with chips on top. Again, this is kind of a typical way that people that are doing, say, ecological restoration will often put down cardboard and then throw chips on top. So these are just common ways that gardeners and others will mulch their soils. And so you'll notice that all of these things are two-dimensional mulches, with the exception of the arborist wood chips. And so the two-dimensional mulches, the plastic, the fabric, and the cardboard, are what we call sheet mulches because they are two-dimensional. So we collected data over a number of weeks, and we repeated this. So we had replicated data. And this is the technical part, which isn't that important to know all the bits and pieces of, but just so you know, we had a way to analyze the amount of carbon dioxide, and that was with a lycorometer. We had an oxygen gas analyzer. And then you can see in this third photo, this is the setup where you have the mesocosm, which is now sealed so that oxygen and carbon dioxide can't go back and forth with the room atmosphere. And this is the way to be able to measure both below and above the system to see how much oxygen and carbon dioxide is in the soil and how much is sitting above the soil. And so here you can see the sampling up close. Whoops, sorry about that. This lower port is how you sample the gas level within the soil. So that's underneath the mulch. And then this upper one is testing that same gas above the mulch. And so any difference there would then be attributed to whatever that mulch was. And then you take those gas aliquots, you put them in these 2 meters, the gas analyzer, and also, the CO2 analyzer, as well as the oxygen gas analyzer, and then you get your data. So that's how we collected the data. As I said, it's a very simple system, but it does set a baseline for what different mulches will do. So what I did is I constructed a graph from this because it's easier than looking at the numerical data. And so a couple things about this graph. This particular one is just for carbon dioxide movement. And it's a coefficient, and all that means is that this number never changes, regardless of anything else that's going on in terms of temperature or water content or anything. This is simply a measure of how various mulches will slow down carbon dioxide movement. And so we did the same thing with oxygen gas as well. The second thing to note is that this graph is an exponential graph. So like with pH or with volcanoes, you know how each, earthquakes, how each gradation is a factor of 10. So you'll see that each time we go from one line to the next, it actually is a decrease tenfold. So the bare soil, our control, had the fastest gas movement because nothing was over the top of it. But I need to point out that doesn't mean that bare soil is a good choice, because bare soil in nature is never uncompacted. And in our system, which was experimental in a lab, there was no compaction force. And so bare soil would normally have a much lower coefficient of gas diffusion just because it's compact. But this was our control. You'll see the next one is the wood chips. And it was about 10 times slower for carbon dioxide movement than the bare soil. Cardboard was 10 times slower than wood chips. And I need to point out that the cardboard is one single layer of cardboard. Okay, so when you're extrapolating this to what would happen with a lasagna mulch, you've got a lot more stuff sitting on top than just a single layer of cardboard. Then the landscape fabric is about 100 times worse than the cardboard, because even though it has all those little holes in it, those little holes get filled up with soil pretty fast. And then the polyethylene mulch was over 10 times worse than the fabric. So you can look at this change and understand that using a plastic over your soil is about 10,000 times worse than using nothing at all. So this is a really nice guide to show you what will happen under very simple circumstances. So we can see that sheet mulches, cardboard, landscape fabric, and polyethylene mulch are going to be less permeable by gases than wood chips, because wood chips are a chunky, coarse material, and oxygen and carbon dioxide move through that much faster than they can move through these sheet mulches. So these are the data that came out that are really useful as gardeners are making their choices. And we published it in this particular journal. It's not something that is free, it's not open access, but I do have a copy of it that I can send out by email if anybody wants to read it. It's full of calculus, so if you're a math fan, you will love this paper. But the important note out of the abstract said that among the mulches tested, wood chips are a preferred method of mulching in terms of providing best gas permeability, particularly in landscape conditions. And so that was meant as the practical part of this, for the takeaway message for those of us that garden and do landscaping. Okay. The second area of or my second designation for practices, products, and phenomena is the misapplied science. And so these are things that are based on science practices, but really used in agricultural production. And so agricultural production, of course, is going to be high intensity, usually a monoculture, and usually an annual system. So it's nothing like what we have in our gardens and landscapes. The closest would be maybe your vegetable garden, but most of us aren't growing just one vegetable. So it's really not comparable. And so you really don't want to take these types of products and practices that are used in agriculture and then apply them to a non-agricultural setting. And the example I'm going to use here is Epsom salts, because that's one of the things that is, again, it's a do-it-yourself thing. It's all over the internet about all the wonderful things Epsom salts will do. And the basic thing is that it will turn yellow leaves green, and it even tells you on the box here for lush green, healthy foliage. So we have to step back and say, okay, exactly what are Epsom salts? And what they are is just magnesium sulfate. So it's got magnesium in it and has sulfur in it. And both those things are plant nutrients. They occur in more things than Epsom salts, but this is where that emotional appeal thing is, that if this was, being recommended and marketed as magnesium sulfate, it wouldn't have nearly the cachet that Epsom salts does. So there's this emotional appeal, especially when you think about the way that people, before we had all different kinds of foot treatments, might sit and bathe their feet after a hard day working out in the fields. So this is something it harkens back to an easier or simpler time, not easier, but a simpler time, and it just has that appeal. It was used quite a bit in fruit production about 100 years ago or so, not so much anymore because of the issue of nutrient overload. And as I said, we'll talk about organic matter and nutrients a little bit later. And it makes water feel silkier. So that's the other thing, is that, it has that cachet, and we know that because it's a water softener, it makes water feel soft. So it just, we take that positive emotional appeal and then we apply it to our gardens. So what we're told is that, that the Epsom salts will repel pests. So if you've got rats or voles or any kind of little gnawing critters, it'll repel them. If you've got slugs, it repels them too. And so when I look for the evidence in databases, I put in all the keywords and I go searching, and there's absolutely no published evidence at all that talks about this ability, especially how it would work, because that's what I was trying to figure out. How would magnesium sulfate actually do this? And there's nothing out there on this. You're told that it's really great for roses. In fact, the American Rose Society recommends the use of Epsom salts on roses. So you spray it on the leaves, get green leaves, you put a handful in the soil when you're planting bare root roses. And again, looking through literature exhaustively, there's just no research at all to support this. And again, it's nothing that I can figure out, even a theory of why it would work. Magnesium is part of, the nutrient system that helps make leaves green, but the main thing that will green leaves up is nitrogen. And I think most gardeners probably know that. And that goes for turf as well. So you're told that if you've got yellow spots in your turf, all you do is you spray on, a solution of Epsom salts, and that will green up your turf. And again, going through the literature, I found not exactly nothing, but I only found one paper. And the one paper had to do with adding magnesium sulfate to pasture land as a way of treating magnesium deficient cattle. So in other words, putting this on the turf, not the turf, but the pasture grasses would allow cattle to take up the magnesium, and that was a way of treating magnesium deficiency. But it was nothing having to do with greening up the turf. It just happened to be words that appeared in one article. So literally there is nothing out there that's published in peer-reviewed literature that supports the use of Epsom salts. So I'm again working on that. It hasn't been published yet, but I'm trying to figure out where. It's hard to publish negative results. Some journals are getting better, but it's tough to find the market for this. But I'll show you what I found. And I used plants in the greenhouse. I used 2 different types of plants during my 2 different trials. And I had a total of 30 pots. And so 10 of those pots were controls. So all they got was distilled water. 10 of those pots got magnesium sulfate applied at the rate that is recommended for fertilizing plants. And then 10 of those pots got a conventional fertilizer. In this case, it was Miracle-Gro. And the reason that we did that is this is it's a double control. And so if you're promoting something that is going to be better than a fertilizer, you know, a conventional fertilizer, then you have to compare it not only to a real control, which is no magnesium sulfate, but you have to compare it to the conventional fertilizer too. So every month I would give them their dose either of water or of magnesium sulfate or of Miracle-Gro. And of course, these things got watered every day anyway. So they were well hydrated. They were planted in a new potting mix. And the data that I collected are here. And as you can see, the number 1 is the control. So things that received water only or received Epsom salts were basically no different. They weighed almost exactly the same. And so these are average fresh weights. So it's an average of 10 plants for each of those. The one with Miracle-Gro did a lot better, about 50% better, which is no surprise because Miracle-Gro contains nitrogen. And nitrogen is almost always the limiting nutrient for plant growth. So again, I did this twice, different plants, got exactly the same results. And so this, when I figure out the right place to publish it, will be published as evidence that using Epsom salts does not take the place of a conventional fertilizer and really is literally no better than water. So this is when it's important to test your soils before adding magnesium or anything else for that matter. And I can't overemphasize the importance for having a basic soil test. And it's just like if you change doctors and all of a sudden you've got someone who's dealing with your health and they don't know anything about you, you know, you get to run a battery of tests so they can find out, you know, all your blood work and your various hormone levels and everything else. And it's the same thing you need to do with your soil. You need to have a basis for which to make management decisions. So when you get a soil test like this that says that magnesium is above optimum, then don't add any more, because nutrient toxicities are really hard to change. It's hard to draw down nutrients to an optimum level. And so above optimum really isn't even a very good designation, because that actually sounds like maybe that's, you know, superlative. Well, it's not. It should say toxic is what it should say. So when you have too much, it's not a good thing. And I do have a peer-reviewed publication out on this. It's again a free download from Washington State University that talks about kind of the history of Epsom salt use, both in agriculture and in home gardens, and then explains basically what I just told you now, but with more detail and with references. Okay, and the third category for these various practices, products, and phenomena is the over-extrapolated science. And so this just means things that work really well in the lab, that in fact they've published and you can win awards and all kinds of great things in the lab. But once you move this outdoors, it doesn't work for a variety of reasons. And I've now expanded this category to include phenomena that you can see happening in the lab, but that doesn't work outdoors either. And so this is just how, you know, my whole myth busting has evolved to include phenomena as well as products and practices. And so because I'm including that, I want to talk about allelopathy. And allelopathy, you will be familiar with, because you will have heard that you should not plant things under black walnut trees, because the black walnut trees contain juglone. They make this chemical and it leaches out of their roots and every place else, and it kills plants underneath. So you'll see pictures like this and you're told this is from the juglone. So allelopathy literally means killing others. Allelo means other, pathy means death. So allelopathy is the ability of plant extracts to kill other plants. And this was something that was discovered almost 100 years ago in walnuts with this chemical juglone. Walnuts are not the only plants that make allelopathic chemicals. This is how plants survive. They make things that kill other things because they can't run, they can't hide. They use chemistry to do their work for them. So plants will make a lot of things that kill people. They make a lot of things that will kill other plants. So allelopathy is a thing, but it's a thing that works really well under lab conditions, but doesn't once you move it outside. And the way it works indoors, let's say you have a chemical and you're curious on whether or not it's going to kill plants. So you take Petri dishes and you take, usually the standard is to use lettuce seedlings. It's Grand Rapids lettuce seeds. And they're on Petri dishes with filter paper and with water. And then you add this chemical. And if the lettuce seedlings, shrivel up and turn brown, that means that chemical has killed them. And that's kind of the gold standard for determining if something's allelopathic. And it works really well. It's replicable. It's good basic science, but it's science literally in a Petri dish. So we have to think about that as we explore allelopathy in a larger sense. And this has been the problem. And I'm not going to say that gardeners are the ones that are at fault for this at all. It started with scientists. In fact, as I recall from the story, that the scientist who was involved in discovering and describing and isolating juglone had at home noticed that his tomato plants, which weren't doing very well, were close to a walnut tree. And so because of the work he was doing, he immediately jumped to the conclusion that walnut tree was what was killing his tomatoes. And this became a very exciting thing because people had seen, once they heard this, they started saying, yeah, I've noticed that things around my walnut trees aren't growing very well either. And so these lists started getting made of all these plants that walnut trees would kill using this chemical. Oops, sorry. But as I said, this was jumping to a conclusion. And a more scientific way of saying that is that when you see two things that are happening together or that are correlated, if you then say, well, one's causing the other one, that's causation. And you can't jump to that conclusion without evidence. But that's exactly what these scientists did and have done and continue to do to this day. And in fact, there's an entire scientific journal called the Allelopathy Journal, and there's nothing in there except for publications on allelopathic chemicals, mostly demonstrating that, yes, you see this happening in Petri dishes in the lab, and then again, jumping to conclusions that this is what's happening in nature. And I bought into this too, because if you've got a body of science that says it's there, and you're not looking at it really, really critically, you can just gloss over the fact that you've got this jumping to a conclusion. So, there's these nice diagrams of, walnut trees and how this chemical gets out of them, various ways. And there's no doubt this happens because the walnut trees do produce a lot of juglone. It does get into the environment. Sorry about that and what that happened. Plants can grow under black walnut trees. Oh my goodness, I've got captioning going on, sorry. There you go, is that better? Hopefully that can get edited out there. I must have just hit something wrong with my cursor. So this was the fly in the ointment that all of a sudden other gardeners and scientists were saying, well, wait a second, we've got black walnut trees and there's all these plants that grow under them just fine. So this became a little bit of a problem, and in response, these very complicated lists got made. One that was a list of juglone sensitive plants and one that was a list of juglone tolerant plants. And had I been thinking about this more critically years ago, because I'm a physiologist, my first question would have been, well, what is it about the tolerant plants that is different from the sensitive plants? And to be honest, there's nothing. Excuse me. There's nothing out there that would be a good theory on why some plants would be sensitive and others would be tolerant, because the plants that are in those lists are all over the place. They're not grouped in, not separate groups, not separate families. It's just a list of plants without any kind of real connection. So there isn't any real physiologically based reason that this happens. And so that became the question is, okay, if we don't have a theory on why it happens, why do we believe it happens? And so the trick is to go back to those lists and figure out where the research was that developed these lists. And maybe there's some answers there that will tell us about, the theory. I can't figure it out. So what happened was, and my publication on this talks about it in a lot more detail. It's really quite fun. I went backwards in time through all the literature, finding that allelopathy can be demonstrated in lab experiments, and it works really, really well. And then when I found these lists and I took them backwards through time, I came up with two publications that they were attributed to. One was a publication from Ohio State University, and that one has been out of print for 25 years. They don't release it anymore because it hasn't been updated. And at that point, they weren't peer reviewing their fact sheets and manuals. And the other one, what supposedly came from Cornell. And I couldn't find either of these online. I mean, I looked and looked and looked. And so I finally got a hold of Cornell because I have a graduate student who works there now on faculty. And I asked her if she could help me, get in touch with the people that could find this in their archives. And so she got in touch with the library as well as Extension Publications. And they spent about 2 weeks going through stuff. And they finally came up and said, this paper doesn't exist. The author of this paper was never on faculty. We don't know who it was. We have no idea why this publication is being cited over and over because it doesn't exist. So this whole thing about allelopathy happening in the field is based on lists of plants that supposedly came from publications that don't exist or that aren't current. So this is just frightening that we've gotten to that point. And all we have to really do is again, step back and think about, well, what happens in nature? And this is what some scientists have now done. When you see pictures like this, and this happens to be actually in Ontario, and black walnut is a very commonly used landscape tree because it's cold tolerant. And Ontario is full of black walnut trees with lots of plants underneath them. And what researchers have found is that, yes, that black walnut does release juglone into the soil environment, but we forget there's microbes there. There's fungi and bacteria, and the juglone is just another chemical for them to break down and get energy from. And this isn't what's happening in the lab. It's not happening in the Petri dish. But once juglone gets into the soil, it's broken down. So it doesn't have an effect on plants and landscape. And you can tell looking at this nice landscape, I mean, there's all kinds of herbaceous perennials and other trees and shrubs that are underneath this black walnut, and they're doing just fine. The trick is water. And if you don't water your landscape enough, black walnut trees, like any other large woody plant, is going to be a water hog. And if you don't supply enough irrigation for newly planted things, they are going to suffer. And if they're not shade tolerant and they're growing under the shade of a tree, they're going to suffer. So this is nothing more than resource competition. And black walnuts were just the unlucky poster child for this because it happened to be a tree that was being studied for this particular phenomenon. And any tree will do this. Cedar trees are, ones that are arborvitae that are used as hedge plants are particularly notorious for just sucking up all the water around there, but they're not targeted with being allelopathic, even though they also produce allelopathic chemicals. It's just juglone and the whole jumping to a conclusion that wasn't supported with evidence. So it's a fascinating story. And I really encourage you to think about this when you're thinking about claims about something causing something else. And that just because you've got two variables that are occurring at the same time does not mean that one causes the other. And here's a great example. Okay, if you look at the data from 2000 to 2009, perfect correlation between the per capita consumption of cheese in the US and the number of people who died by becoming entangled in their bed sheets. Okay, and that, if that doesn't make you laugh, nothing's going to make you laugh. And we certainly wouldn't make the argument that one is causing the other. They just happen to be occurring at the same rate for whatever reason. And we have to realize that unless you've got evidence to the contrary, and by evidence I mean published peer-reviewed evidence, you can't just assume that two things that are correlated is going to be a cause and effect. They just happen to happen at the same time. And I got that particular diagram from the Spurious Correlations website, which is a very fun website. It has tens of thousands of these types of correlations. As I said, if they don't make you laugh, nothing will. And here's the publication I produced on this a couple of years ago. And I think that, again, you'll find it a really interesting story. It's, again, peer-reviewed through WSU and meant for a gardening audience. So hopefully you will enjoy that. Okay, so we're going to talk about just briefly some of the things that we should do as gardeners that will make many of these practices and products unnecessary anyway and work better than most. The first thing is we've really got to go back to that soil test that I was talking about. We want to avoid excessive nutrients. It's easy to add a nutrient if it's deficient. It's really hard to bring high levels down. So when you get a soil test back like this, where it says that everything is above optimum, that means you've got nutrient toxicities. And the phosphorus in this case is over 45 parts per million. And they tell you in that chart, it should be somewhere between 4 and 14. So it's way more than you need, and excess phosphate causes all kinds of problems. Now, in this particular landscape, the gardeners did not use fertilizer per se. They used compost or organic matter as their source of nutrients. And so we want to look at the organic matter, which in this case was 8.7%. And we can say without error that this amount of organic material is too much for this landscape because it translates to too many nutrients. Okay, so what we tell this gardener is, okay, you need to stop putting down compost. Don't add any fertilizer. It's time to be drawing this nutrient load down. And you may have to add nitrogen, but you should never add anything else that isn't shown to be deficient. Okay, so you could go back and say, okay, so 8.7% is too high for organic matter. And in this system, it is. But it doesn't hold true for all systems. And this is why it's so important to have a basic soil test. Here's another one to look at. And the first thing you'll notice is that almost all the nutrients are at optimum levels. Okay, right in the middle there, perfect levels. Phosphorus is a little bit low. This hardly ever happens in gardening, in gardens and landscapes. It's usually excessive. And you can look at the number there. It's 3.4 parts per million. So it's a little bit low, but the fact is that nothing in this system is showing phosphorus deficiency. So that's the second part. If you have a deficient nutrient and you're not seeing deficiency symptoms, you don't need to add it, because it actually isn't a magic number for all plants. That's relevant to all plants. A plant's going to be a little bit variable in how much phosphorus they actually need. So if you have something that says it's deficient, but you're not seeing symptoms of deficiency, don't add it. You're in good shape. So this system is actually a sustainable system. But look at the organic matter. It's 12.8%, which is really, really high. And 2 years ago, I would have said to anyone showing me this, you've got too much organic matter. Stop adding so much organic matter. Well, because this is my soil, I can tell you exactly why the organic matter is what it is. We don't add anything except for wood chips as a mulch. But this, we live on our family farm. We've had this in the family for over 50 years. And ever since this place was built, it's never really had anything added to it except for an annual leaf fall from our Gary oak trees. And Gary oak leaves are very slow to break down. They get incorporated in the soil, but the leaf material, as you know, it's really tough and it takes a long time to break down. So that's what the organic matter is. It's all those Gary oak leaves that have been accumulating for centuries in our soil that break down so slowly that they don't give a fast release of nutrients. So for our system, 12.8% organic matter, because we know where it's coming from, is fine, because we can see from the nutrient levels that everything is optimum or even a little bit low. So this is why a soil test, and this soil test came from the University of Massachusetts at Amherst, it's $15. And there's a wealth of information here that will help you with so much. For instance, you'll notice, and this has nothing to do with today's talk, but our aluminum level is actually quite high. Now, this is just because the soils around here are naturally high in aluminum, but this is an issue for if you're doing vegetable gardening, because it's a lot of aluminum, you want to be careful about vegetables that will take up aluminum because it's toxic. So this is the type of thing you can find out by having a soil test. You'll get all kinds of great information. So again, just making sure that you keep your nutrients in the optimum range means that you're doing things perfectly. And as I said, that we add wood chips, and the reason we add wood chips is that research continues to show that that arborist wood chips, which include needles and leaves as well as wood parts, is what's optimum for supporting soil life, especially mycorrhizae. And mycorrhizae are optimal for most roots, woody plants and non-woody plants. So having those beneficial fungi in your soil and supported with this woody mulch layer is critical to a healthy landscape. The more diverse your landscape is, and by that I mean, you know, both the types of plants you choose as well as their relative sizes, the more resilient it is, and you will have more wildlife attracted. You'll have fewer pests and fewer diseases. So when you're looking to, you know, to decrease your inputs of things like fertilizers and pesticides, the way to do that naturally is just to have a really diverse landscape, which brings in beneficials, which help you maintain those pests should they arise. So just to wrap up before we do some questions, I wanted to just give you some information about my resources, should you care to use them. I mentioned the literacy guide, which is one of the peer-reviewed publications I do for extension at Washington State University. And it is on our gardening website, which is a Master Gardener resource that WSU provides. And it's also available other places too. So if you ever have trouble getting this, if you just search for the title and you happen to do that in quotation marks on Google, it'll take you to some place that'll have the PDF, and it's free. So it doesn't matter which link you're getting it from, just go ahead and use that. There's my myth page, and this is kind of the way that I got started back in 1999, 2000, was with my white papers on different myth topics. And those are still there, and there's about 70 or so of them. I haven't added to them because all of my things now are going through peer review and getting published as fact sheets. And so I haven't updated all these to become fact sheets yet, but I'm slowly working on it. But they're still out there as white papers for you to use as well. I've got a number of books that I've done over the years. Those white papers I just mentioned, I use those to compile 2 books. The Informed Gardener, The Informed Gardener Blooms Again, which each one has 35 different myths, and I talk about what the myth is, what the science is, and then give you, you know, some alternative strategies. Then there's also Sustainable Landscapes and Gardens, which is kind of a master gardener approach to a landscape, but it's not regional. So in other words, this is information that's good anywhere, not just in Washington State. How Plants Work, which is plant physiology for gardeners. It just tells you why plants do the funny things that they do. And then, as Lee mentioned, recently helped with the 3rd edition of Gardening with Native Plants of the Pacific Northwest. And this was a book that Art Krukeberg started years ago, and he passed away during the revision of this 3rd edition. But it's a gorgeous book that has almost 1,000 plants, and it's a curated collection of plants that do well in garden conditions. And my colleague Sammy Gray managed to convince many photographers to let us use their photographs without charging for it. And so it's a beautifully illustrated book. And then there's the Science of Gardening series, which if you really enjoy watching me, my husband will say you're crazy. He's not in here. But it's been a pretty successful series in terms of being able to see a lot of the things in a kind of a laboratory or outdoor setting that I talk about. And then recently, a colleague and I have been publishing a series in the NACA Journal. And the NACA Journal is the National Association of County Agricultural Agents. And that sounds like a really strange place to publish, but that's how Extension started, was as agricultural agents. And it's extended way past that now. It's not just for farmers, it's for people in urban areas as well. So this has been a really good way for us to get information out to educators as well as the public. And so we do garden myth busting. This is a peer-reviewed journal. It's open access, so you can find them easily. And every December we publish one of these. And so the first one we did was looking at the literature on landscape trees. And then we've done a couple of them on soils, specifically looking at soil structure and function and soil nutrition. So those are great resources because, again, they're free, they're science-based, they're peer-reviewed, and they do a lot of myth busting in one article. And my colleague is Dr. Jim Downer, and he's kind of my counterpart in California. So we do a lot of the same things, and we decided to join forces and start publishing this as a way of reaching people more broadly. Our blog we've been doing since 2009, and so every week we have a new post. Our blog members have changed throughout the years. We started with, there was 4 of us that started it, and all of them except me have gone on to other things, and I've gotten new bloggers, and so we still continue to blog every week. We have a Facebook page, and our page is kind of a clearinghouse for interesting articles that come out, or websites, all science-based. And then we have some fun stuff in there too, just to keep it interesting. But it's a great place to find information that comes out more than once a day. My administrative volunteer is great at just keeping this site fresh. So that's a good place to look on Facebook. But if you really want to have an interactive experience, and if you've got questions or you just want to see what other people are doing, our Facebook group, which is the Garden Professors blog group, is 24,000 strong, full of expertise from all over the world. You don't have to be a professor to join it. It's just that we expect people who are giving answers to know what they're talking about. So lots of people give advice that are not professors, and they're spot on because they have done a lot to learn on their own. And so we pride ourselves on being, as far as we can tell, the only science-based gardening group on Facebook. So we are really sticklers about using good science to give people advice about their gardens. And the nice thing is as you can see down here, there's a little magnifying glass. And so you can go back through our archives since 2011 and find discussions on all kinds of topics. So these online resources are really nice because the longer you have them, the more rich they become in terms of good information. So with that, I know there's some time left. I did that on purpose so that we can talk about things that you have questions about. And so maybe it's an information source that you've heard about, or maybe there's another product or practice, and there's lots of them. That handout that I provided you has a whole list of common products and practices that I've got information on. Or if you're curious about a phenomenon like the allelopathy, or maybe you're wondering if there's lunar influences on plants, any of those things are fair game, and I'll be happy to take your questions.
Okay, so Linda, we have our first question is, can you please give recommendations on how and where to get your soil tested?
You bet. So we used to be able to get soil tests from Washington State University, but many years ago, as part of the budget slashing that occurred, and this is decades ago, they got rid of the soil testing lab for the public. So we do not have a university lab for testing soils. But the University of Massachusetts at Amherst has been my go-to place for over 20 years. And the reason is because it's a university lab, so they're not selling proprietary products. They're going to just give you good information. They are specifically tailored towards uses like gardens and landscapes. So you're able to actually mark, that you're talking about vegetable gardens, or you're talking about lawns, or you're talking about trees and shrubs. And it's very inexpensive compared to private labs because it's a university lab. They do all kinds of other work besides the work for the public. And so they're able to really keep the costs down. So if you go online and you you just put in UMass Amherst soil test, and you will get their website. It explains how to take your soil test, how to send it in, or take your soil sample, how to send it in, and then you'll get your results back by email. And they're fantastic.
Excellent, thank you. Does anyone else have questions? That was the only one that's come in through chat. So you guys can write your questions down and I will ask them anonymously, or Does anyone want to raise their hand to have questions for Linda?
I have a question.
Sally?
Oh, good. You could see me even.
I
Uh,
can.
I have not ever tested the soil. However, I have a yard that is about 200 feet deep and 300 feet wide. If I were to soil test it, even I know that the soils are quite different. One is on the waterfront side and one is toward the back. About how many bits of soil and how do you prepare soils to be tested and sent to Amherst?
Okay, well, the website will explain a little bit about how to do this, but I'll just kind of explain part of it too. So yes, you're right that your soils are going to differ not only for what you're using them for, but for where they're located. So one thing you'll want to make sure that if you're sending in different samples that are for different uses, you don't want to combine them all together. So you'll have to send in separate ones. So when I do mine, I do one that has landscape beds, and I do my raised beds, and those are my vegetable gardens. And then I do underneath our lawn. So we do 3 different types, and you can do as many types as you need depending on what you want to grow there. And then, as you say, if you've got dramatically different conditions on one side to the other, as you do on the waterfront, just make sure that you keep those separate too. And so this can, you can spend a little bit more money than $15 because you're going to have multiple tests. Mm-hmm. But for instance, if you're looking at the water side and basically all you have is landscape beds, let's say, all you do is you take several samples from that area that is being more impacted by salt spray, and then you combine them all together and you shake them all up, and then you take one sample from that. And that's going to be the average. And that way you're not having to do so many separate tests. So the main thing is to make sure you're separating them in terms of your use, and you're separating them if they're drastically different in terms of their environmental conditions. So I think that for your situation, you've got the front area and you've got the back area, keep those 2 separate. And then within those, whatever you want to use them for.
Thank you.
Sure.
Okay, we've gotten a couple more questions in through chat, and I'll just read them in order. The next one is, how do you determine if wood chips are arborist chips? What is the difference between those and just plain old wood chips?
Oh, good question. Okay, so arborist chips are those that come from a tree service. And so when you're getting a branches chipped up or whatever, it doesn't matter what trees, it doesn't matter, who's doing it. The best chips are the fresh chips. That being said, sometimes you can't get that, and especially I'm sympathetic to the fact that people on islands may not be able to get them as readily as others. So what you don't want is you don't want bark. You don't want bark mulch. And the reason you don't want bark mulch is because it's just part of the tree, and it happens to be the part of the tree that it's water resistant. So the function of bark on a tree is to keep things out and keep water in. It's kind of like wax on a car. So making a mulch that's out of a waxy material means you're going to have a hydrophobic mulch. It doesn't absorb water. It doesn't release water. Water doesn't pass through it easily. And it just makes for a pretty bad soil. So if you can't get arborist chips, and so again, these would be from a tree service, anyone who's taking, woody material and putting it through a chipper, the next best source would be a recycled wood product. And so, for instance, I think there's a bigger market for this now. What recycled wood is leftovers from making lumber or other things that are not treated with chemicals. It's just wood, but it's been processed, so it doesn't have all of the green bits anymore. And it's almost as good. I've done research on both, and recycled wood mulch is almost as good as the arborist chips in terms of how well they affect plant growth. You just want to make sure it's coarse. You don't want sawdust, because sawdust is too fine and it makes a compacted layer. So you need nice, coarse and chunky. And as long as it's not bark and it's some kind of wood base, you're in good shape.
Excellent, thank you. The next one sounds like a duplicate to me, but you may be able to finesse it a little more readily than I can. The question is, I wonder if I have different areas in the garden, raised beds and terrace beds, should I have different areas tested?
Yes, and for the same reason, because if you're doing raised beds in there for veggies, you know, that's a little more like crop production. And that means you're going through and you're changing that every year. So in other words, you know, you're planting, you're harvesting, and you're starting all over again. And for terraced beds, for instance, I'm assuming those are landscape beds, you're not going through. You might be planting something, you might be taking something out, but you're not doing this, you know, complete removal of plant material. And that does make some differences in terms of what they will tell you about how to manage your soil. So if they know that you're using the soil for vegetable production, they may say, you know, be sure to add some nitrogen or something like that.
Okay. And that was a nice segue to the next question, which is, how often do you get your soil tested?
That's a really good question too. So I'm going to actually test mine again this year. So I got mine tested 2 years ago. We don't add anything but wood chips, but I'm kind of curious, and that's why I'm kind of curious to see if the nutrient levels have dropped at all. I didn't notice any issues with our vegetables last year, but that doesn't mean that I may be getting low in something. I just don't know. So I would advise for vegetable gardens in places where you know that you're using a lot of nutrients and maybe things aren't going back in, or is, you know, every couple years, just to make sure that you're not getting deficient in something. In terms of landscape beds, I would say just do it once, unless you've got something you have to address. And so for us, you know, everything's optimal, except, as I said, our phosphorus is a little bit low. We don't have any deficiencies. There's no symptoms. And so unless something happens that I'm wondering if we've got a nutrient issue, I probably won't test them again for years. So landscapes just don't change that drastically. And the reason is because we're not harvesting them. We're not taking all that material away. Plants recycle a lot of their own nutrients. And so again, unless you've got a toxicity, and you want to see that's decreasing over time, I wouldn't do it more than just once. But that being said, as I said, if you have a toxicity and you're trying to show that it's going down, then you're going to want to test it maybe every couple of years.
Okay. The next question is, I have raised beds for veggies and flowers. Would you suggest a store-bought soil tester? And if so, do you have one that you would recommend?
There really isn't a good store-bought soil tester to use. Unfortunately, the tests, especially for things like phosphorus, require really sophisticated chemistry that you just can't do in a kit. So, but that being said, you can test pH yourself. And for pH, I would just go to, you know, one of those pool stores where they have stuff for taking care of your pool, and you have pH strips for that. And you can use those for testing soil. You can do hand tests for texture and for compaction and drainage. And those are all things that are easy to do yourself. You can even do your own texture analysis and there's ways that you can find the directions on the web, but you just take soil and you put it in a quart jar along with water. You shake it up real well, and then you look at the layers that fall out, and you can kind of tell what kind of soil you have. And plus there's a finger test you can do for soil texture. So there's a number of ways to test, you know, structure of your soil and a lot of the physical characteristics. But for the chemistry, you really have to go through a soil testing lab, because there's nothing on the market that allows you to do that accurately.
Okay. This is the last question that I have in chat, unless anyone else has something they want to send. Is it okay to lay down cardboard with wood chips on top in the paths between the beds, or will that affect the soil in the beds somehow?
Good question. It's not as bad because you've got edges there. And so things actually can kind of get, you know, gas can diffuse around the edges. So it's not as bad. So if you're using an area where you don't want things growing anyway, I mean, sure, that little patch there under that cardboard may be, you know, may have less oxygen getting into it. But unless you've got a lot of roots there from desirable plants, it probably isn't an issue. But I will tell you that I use wood chips, just wood chips without the cardboard, in between my raised beds. And it works just fine. You don't need to have any cardboard there at all. You just have to replace the wood chips as they start to decompose. And so I just recommend using the chips without the cardboard.
Okay, we have a small follow-up to that, but is it okay if the cardboard and chips are around a raised bed which has its own soil?
Sure. But again, I'd even suggest that maybe as an experiment, you try, doing around part of your raised beds is to just use the chips. And what I've found is the best way for making this work is that if you take your weed whacker and you scalp everything down to the ground, and then you put a nice thick layer of chips over it, and you continue to keep chips over it to a depth of at least 4 inches, it will keep the weeds out. And then you don't have to have the cardboard at all.
Excellent. All right, any other questions, you guys? Elena, I'm going to turn it back over to you.
All right. Linda, thank you so much. For the talk today and also for all the materials that you provide. I just wanted to point out to listeners that the library has a copy of you, or maybe more than one. Tony Saruda worked with them to make sure they had copies of the great courses
Good.
things. So those are available, and we're putting links and all the other things up, so they'll be available to people to easily find as well. And thank you for all that you do for gardeners.
Oh, I'm so happy to do it. I enjoy seeing you all virtually. And I hope that when this is all over, and I'm getting my second shot at the end of the month. So I'm hoping that next time that you ask me to speak, you'll actually be in person.
Oh, I hope so.